Well, I see 1 o'clock on my screen, so I think we should probably make a start. First off, a quick audio check. Can you hear me successfully? I'm going to take my mask off because I'm speaking, and just for clarity for remote participants. I hope you don't mind that. Thank you. Hello. Welcome to our IETF115-DTN working group meeting. So just for clarity, this session is being recorded. We're doing this through Meet Echo. It will obviously excitingly all be on YouTube afterwards. So you can show what you did at IETF to your friends and colleagues when you get back home. Next slide, please. So as this is an IETF meeting, this is covered under the Note well. So I'm assuming most of you have attended an IETF meeting before. Oh, okay, jolly good. If you have not, you need to read the Note well. This covers IPR. This covers your participation at the microphone, in the chat, and within the meeting in general. It also covers your basic behavior. Heated discussion is fantastic. Abuse and bullying is not. There is a relevant codes of conduct, relevant information on copyrights, patents, participations, and the general standards process, all documented in these very nicely written BCPs. Please follow the links if you have any questions. As with most things, you have been told about these things. You can now no longer claim you are unaware of them, but we're all grown-ups and we will assume that we're going to behave responsibly. Anyway, next slide, please. So, tips, because we have still have a large number of remote participants thanks to the tail end of COVID, please make sure you sign in to Meet Echo remotely, obviously, but also in the room so we can operate a single queue. There's a really nice raise hands button you can click to join the queue. So please use that rather than just standing at the queue. Remote participants, try to avoid some feedback by keeping your audio and video off unless you are actually presenting or chairing. If you're asking a question, obviously you will need audio. Video is optional. Strongly recommend a headset to avoid the usual audio feedback problems. Hopefully, after 2 and a bit years of COVID, we're all pretty good at remote meetings over video conference, but problems happen. Next slide, please. So, the agenda is at that URL. We will also put it on the screen in a second. The Meet Echo information, for those obviously who are not remote and can't see this, but that information is there for your reference. If you get stuck with anything during the meeting, there's a URL there for an FAQ, which should hopefully help you dig out of that hole. Next slide, please. So the agenda, we are doing the first 5 minutes from the chairs, well, currently from me. Then we have a 35-minute discussion on the IPN naming scheme update from myself. Then Brian Cephas is going to present BPv7 administrative records. We're going to do the COSI BPsec security context records again with Brian. We've given him 20 minutes to do both, but there's 2 topics in there. Then Sarah Heiner is finally going to get a chance because she got bumped from the 114 agenda to talk about the DTN management, DTN-MA architecture. I think that's double architecture if I think about it, which is all about managing systems across delayed and disrupted networks. Interesting piece. And then Scott Johnson wants to give a demonstration, which is always fun, and we have real confidence it's all going to work remotely from wherever he is in the US about IPv6 support for DTN. So I'm actually really looking forward to that. It'll be great. As usual, we will have a little bit of open mic at the end for any other business. We will absorb that if any of these discussions get heated. I would much rather discuss things as they happen within reason, rather than waiting to the very end and then to dominate the end of Scott's demo with talking about IPN, for example. So we may absorb that 15 minutes. We may have to be quite tight on time if discussions run on. Next slide. Okay, there is the shared markdown-based notepad in Meet Echo. Although we have a secretary here, Adam, who furiously takes notes, please help out. Please, it's a collaborative thing, particularly if your name is spelt wrong, or, I mean, Adam types fast, but occasionally keystrokes are missed, or if you don't think he captured your point correctly, please add to it, it's fine. Equally, to help Adam, if you're in person, can you state your name at the mic nice and clearly so he can capture that as well? As usual, this is an IETF working group. We have a mailing list, dtn@ietf.org. Also, if you need to contact the chairs about anything administrative, subject matter stuff should really go to the normal DTN mailing list. It's for the working group. But if you have an admin issue or want to suggest something administrative, there's the DTN-chairs mailing list, which will go to Ed and myself, and also our AD, Zahed, who I believe I just saw come in and sat at the back of the room. Oh, there he is. He's over there. Great. So we have our AD with us as well, which is great. So one thing I did not do is give a 30-second chance for anyone to bash the agenda. Do you think we have missed something vital? Brian is at the mic first. Go ahead, Brian.
Hi, Brian Seepers, APL. I actually had submitted some additional slides about CLA service definition. If I shorten my other time, will I be able to present on those as well?
If you can fit them into the 2 10-minute sections you've got, I have no problem.
Okay, thank you.
Yeah, can you submit the slides to be updated, and we'll get them into the agenda pack quickly. That's fine. Sorry.
They're actually already in there.
We'll click the right button then.
I'm sorry, I'm still.
Mark is struggling. So Mark Blanchet, join the queue.
Yeah.
By all means, go for it. I feel your pain.
Thank you. Looks like sometimes in this room, the wireless, kind of disconnect, at least on my side. I don't know if it's an agenda item, but I just reposted a draft that I wrote a few years ago about service registry and kind of a application framework. I just want to know from the working group if this is interest to be done or not, or, so at the very end of the meeting, if there's a few minutes left, I wouldn't mind, knowing if people have interest, or the working group, so that I kind of resume the work on that.
Yeah, sure.
Absolutely. Yeah. Share the mic. It's wireless.
Oh, it is wireless. So, no, completely agree. Don't have anything to add to Rick's excellent introduction. And why don't we start with our first presentation, which is Rick.
Okay, so for clarity, I am most definitely taking my chair hat off during this presentation, because this is my draft primarily. I'm the primary author on this, and so I will be representing myself and not acting as a chair of DTN. So I want to make that abundantly clear. And I may stand here for the whole of this Q&A as well to indicate I am not chairing this. So as many of you are probably aware, I hope, I have published 3 revisions of an IPN URI schema update draft that recently, after the the working group adoption call was successful, after the interim we held between 114 and 115, is now being republished as a working group document. So although I am the primary author on this, this is now a working group document and is up for discussion and consensus within the working group. Okay, next slide, please. So a little bit of background for those of you who haven't immediately read it or aren't familiar with the depths of it. This is all to do with the IPN scheme URIs. So a little bit of background. Within DTN, sources, destinations of bundles are described using a URI. So this is the URIs, just like HTTP URLs, UUID URIs, etc. But in both RFC 6260, which was Bundle Protocol version 6, and 9171, which is Bundle Protocol version 7, the IPN schema is defined as node number, which is an unsigned integer, and service number, also an unsigned integer. There is explicit encoding instructions for how to take this general purpose text-based URI and turn it into the relevant encoding for both Bundle Protocol version 6 and Bundle Protocol version 7. So although we are talking about URIs, there are specific encodings for the two bundle protocol versions that are in active use at the moment. But I will just refer to them as URIs. The discussion may touch on encoding, but the format is the key point. So, as defined in 6260 and 9171, and there is some weakness about that total definition, but it's reasonably clear. It's made of two parts. The node number, which is the unique identifier of the node on which a particular service endpoint is expected to exist, and the service number, which is the identifier of that service on the node. Now, the uniqueness constraint is really important. So, in both BPv6, but definitely in BPv7, an endpoint identifier, which is the URI, must be unique for interoperability. If you have a set of connected DTN nodes making a single DTN network, you cannot have duplicate endpoint IDs, i.e., unicast endpoint IDs. You can have multicast ones. IPN does not support multicast. So in the IPN, it's all about unicast. So therefore, they must be unique. Otherwise, you can't deliver the same, you can't address the same bundles as to two things with the same name. So the combination of node number and service number must be unique according to RFC 9171. But in the descriptions in 6260 and 9171, node number is also implied to be unique, following the general pattern of IP address and port number. So this is analogous, but not identical. Next slide, please. So I have, in going through and trying to really understand what's going on with IPN, I have read quite a lot of stuff, and I have some perceived problems which I have attempted to address in this draft. And they are primarily, there is only one IANA registry for node numbers at the moment, and it's called the CBHE registry, which stands for Compressed Bundle Header Encoding, which is a way you do the wire format for Bundle Protocol version 6. It predates Bundle Protocol version 7 and makes no reference to Bundle Protocol version 7. And compressed bundle header encoding isn't used for Bundle Protocol version 7. So perhaps CBHE isn't the right name for the registry, and renaming it requires a document because it's good best practice and it's what IANA requires of us. Not a great issue. Second point, there are some minor inconsistencies between 6260, 7116, which actually is the draft which introduces, and Mark Blanchet is one of the authors of that draft, which introduces these IANA registries and makes the requests and backs them up. But it doesn't change the spec much more from 6260. And RFC 9171 inherits the IPN URI scheme because it was very much in use for V6, seen as a very useful thing to have. But because it's described in 3 different documents, there are some inconsistencies. There is some implementation knowledge that has emerged. There are ways people have interpreted these things into into implemented networks where they slightly deviate in behaviors. For example, the node number uniqueness isn't absolutely explicit. It's just kind of assumed. And really, we should have nice, clean, clear specs for this. And from my perspective, I don't actually care what that spec says as long as it is abundantly clear what the correct behavior is so that we can achieve interoperability, because that's the point of the IETF, is to achieve interoperability between different people's systems. If you're building your own thing, do your own thing, nobody really cares. So the third perceived problem is the single flat numbering space for all node numbers. So this goes back to the Bundle Protocol version 6 days where there were node numbers. It was an unsigned 2 to the 64-bit integer space. Great, lots of room in there due to the way that the wire representation in Bundle Protocol version 6, that could be encoded reasonably effectively. But there was still a penalty for the bigger the number, the more bits need to be encoded on the wire. And with CBOR, that is definitely the case. So there is, if you got an early allocation from this single space, you could encode your IPN numbers in 6 or I think it's 7 octets. If you tried to register one now, and there aren't that many registrations, but they're handed out in big blocks according to the registration policy, which is perfectly valid because you probably do want a fairly big chunk, you can end up with the minimum encoding being 8 or 9 octets. And if, you know, if this gets allocated aggressively, you could end up forced to have a minimum 10 octet encoding, where if you could just use a low number, you could get away with 5. And we're talking about deep space and constrained devices. And having an IANA registry force you to add 5 octets to your source, your destination, and your report to fields in your bundle protocol header just to talk between 2 devices within your own network seems unfair, if I'm honest, and undesirable. And equally, the other problem is in that original CBHE node number registration, there wasn't actually anywhere for saying, do you know what, these really convenient short numbers like 1, 2, 3, 4, and 5, you know, you build one of these things in your lab and you start numbering your nodes 1, 2, 3, 4, and 5 because, you know, they're easy. Those aren't reserved for that use. They're actually reserved to be handed out to someone. So if you then go and fly that, because you built it and it's been signed off by the relevant authorities and you've put it on the top of a rocket and shot it off somewhere, you're using someone else's licensed spectrum, or you're using spectrum that has not been, and I'm putting this in radio terms because I know a lot of people understand that in the space community, you are using spectrum that has been reserved to be handed out to somebody else, which means your equipment that is currently out there, that spectrum may be allocated to someone else. So there is no official unlicensed spectrum to use for experimentation and clear rules about its use. And I also see that as a problem. Next slide, please. So the IPN update document attempts to provide solutions to these. So the first one is to clarify the usage of the IPN scheme URI node numbers and service numbers with bundle protocol version 7. So that's collate all the information we've got between 6260, 7116, and 9171, draw it all together and say, do you know what the rational superset of all of these rules, or the rational intersection of all these rules is? Naught is reserved for the administrative endpoint, blah, blah, blah. You know, it's a pretty short summary of this stuff, and it tries to tackle the uniqueness constraint. And I will go into these in a bit more detail in a second. The second thing is to say the CBH node number registry is a misleading name, and frankly, it's quite difficult to look up, and it's not very clear to see what it is anymore. So let us rename and clone that repository into two registries. One we will call Bundle Protocol version 6 node numbers, because it's for BPv6 and it's the node numbers, and it's exactly what the CBHE registry was, but we'll call it BPv6 because that's what it is, and the same applies to service numbers. And we will make a copy of that called BPv7 node numbers and BPv7 service numbers, and we'll tidy up the allocations a little bit to put in a bit of private space to make sure that we understand it and it's there for people to use, including, and that's the third point, reserving low numbers in that range for private use. So the efficiently encoded, obviously used, and we know people just use, I've built a DTN network where I called my nodes 1, 2, 3, 4, and 5 because why not? That now becomes official unlicensed spectrum. That's fine. I can do that. And I understand it's an unlicensed spectrum, which means I will clash if I am not careful. So don't go fly this where I expect it to be interoperable with other people. It's just putting that clarification in there. And the fourth point is to introduce a new numbering authority. So introduce new numbering authority prefixes to allow flexibility of allocation with efficient encoding. So this is to address the problem with a single flat number range, to say, let's divide it up and make it a bit more hierarchical, and I always mispronounce that word, such that we can allow organizations to hand out numbers in a controlled way that are efficiently encodable and don't need to constantly batter IANA for registrations or allocate great chunks out of a single number range, and still maintain interoperability with probably more efficient encoding. I say probably because you can still do dumb things and end up with inefficient encoding, but it's that is now delegated from the IETF to regional numbering authorities who can make their own decisions about whether they want to be smart or dumb. Mark, you've suddenly joined the queue.
Yeah.
I'm going to go into all of these points in a lot more detail slide by slide if you want to hold it, but keep going.
We can take a question now.
Yeah, up to you. I just want to make sure because the registry actually has private use.
It's
Space.
yeah.
It's just that it's not low numbers.
Yeah, it's way at the top end, isn't it? Yeah.
Then, there's trade-offs here because, private use is typically, in your lab or whatever. Therefore, packet size, you don't matter, right? Bundle size or, whatever. In space or, constraint networks, those, as you said, those, numbers are more important because they're smaller. Therefore, those numbers are more precious to be used in production constraint networks than in the lab. Therefore, I'm essentially at the opposite of the spectrum of you in the private one should be, don't care.
I completely agree with that sentiment.
Okay.
And without the introduction of numbering authorities to solve the encoding problem with a different approach, I completely agree. I will add, ignoring we have numbering authorities, having numbers 1 to 24 is the best thing to have because we're using CBOR and that's 1 octet. So if, and I'm not intending to make it a political point here, but if Roscosmos and NASA both apply to IANA for numbers 1 to 24, how do we decide that? I don't want to put that pressure on IANA and turn it into a massive geopolitical conversation.
That's a registry policy.
I understand it's a registry policy discussion, but I think we can sidestep that whole thing.
We can tight up the registry policy if we want, but that's
It's
kind of a
in which case, can we
related.
come back to this at the end after I've brought in numbering authorities, because I think it sidesteps it.
Bob Moskowitz, and in the issue that you brought up about the size of the header and the space and that, have you looked at all at LPWAN's static context header compression,
Yes.
pronounced chic, and whether chic is applicable in this particular case?
I have. And one of the things I am not doing is altering wire protocols specified for bundle protocol version 7. I do not want to start rewriting BPv7. What I'm trying to do here is clarify text in BPv7 and introduce the smallest possible effective
Okay,
change
as long as
to
you
the
looked at it and evaluated and said, fine.
Yeah, it dropped out of scope in terms of pragmatism rather than any argument about whether chic had an elegant encoding or not. Next slide, please. So quick one, here we are. What are the clarifications I am proposing for IPN as it currently stands for BPv7? And this is, as I said, the intersection between the 3 RFCs which talk about this, trying to work out what actually the common, not the lowest common denominator, but the common intersection of behavior that kind of matches what people have assumed when they're reading it, as far as I can work it out. So they boil down to the value 0 for the, so remember, node number component dot service number component. The value for the node number component must, the value 0 must not be used except as part of the magic IPN 0.0. So within bundle protocol version 7, there is this concept of the null endpoint identifier. It's nowhere, DTN none. And in IPN, that is the magic value 0.0. So you can't use 0 for anything else. It just makes no sense. It would danger, in my opinion. So you can't have an IPN of 0.2. Service number 2, kind of on the null endpoint, doesn't seem to make sense to me. These are all open for discussion, but that one hasn't proved to be contentious. Values greater than or equal to 2 to the 64 for the node number must not be used because you can't do it in a CBOR type 0 unsigned integer encoding. That will change the wire encoding of your CBOR to use big nums. We don't want to go in there The current encoding as described in 9171, which introduces the CBOR encoding, says this will be an unsigned integer. They have a natural limit of 2 to the 64. That's never actually written down. It's implied by two statements, which in combination say that. So I'm just saying it, so there's no confusion. Third, and this is contentious, all IPN scheme URIs for endpoints co-located on a single bundle processing node must share the same value for node number component. And this is contentious because either you read this idea of node number dot service number as analogous to IP address colon port number and think, well, obviously I've got an address for my node and I discriminate on the service on my node. And therefore, my nodes have to be unique. Counter argument is no. Bundle Protocol version 7 makes it absolutely clear that the URI in totality is the unique element. That's what has to be unique. I can have a service called IPN 2.1. Ed can have a service called IPN 2.2. They are both unique, and it doesn't matter that the node number's 2. Personally, I don't mind. I think an argument can be made for both. Yeah, if you allowed node numbers to not be actually the number of a node, and we'll just call them last part or second last part and stop that implied inference that it's something to do with the number of the node. And then for the uniqueness constraints apply, this all works fine. You can have allocation policies for them. It's all good. We're home and dry, and we can do multi-homing, and we can do gateway devices, and we can do all kinds of cool stuff.
So we have a question from Eric, and then we have a question from the chat.
Oh, sorry, I can't see the thing. Go on, Eric.
Yeah, clarifying question. I think what you just described doesn't match at all how I read bullet point 3 here.
Yes, so I put an absolute rule in there, but I've had a number of people come back to me and say, I don't agree with that. I think that's wrong.
Well, so saying that n2 dot star has to be on a single node is different from everything on a single node can have only one node number. Those are two different things.
You're right, and I meant what you said and not what I've written.
So you meant that n dot star is always on node n and nowhere else.
Yes.
Okay, that's not okay. So so bullet point 3 is not in fact correct as written at the moment.
Endpoints co-located on a single bundle processing node must share the same value for the node number command.
Because this implies that a node can't have node number 2 and also node number 3. You're saying they must have the same node number, and that's like maybe not.
Yeah. Okay.
That's an additional restriction.
Yep. A very valid point, and this is why this is the most. This is why this is one of the things we need to discuss, because the other point is, no, let's not do that. Let's say you can only have one node number. It's your node number, and therefore it's got to be unique for your node, because then I can do something like see an endpoint of 2.7, and I know where 2.1 is. So I can send it to 2.1 because I believe it's the right node, even if it's the wrong service. So you're adding routing, and okay,
that's still technically a different thing.
It is, okay, yes, it
Right,
is.
that's-
Having just said that, it is, of course. Yeah, I can do that with 3 as well if you have 2 and 3.
2 and 3, yeah, exactly.
Yeah.
Boom.
Okay, so I'm.
So just to jump in from a time perspective, I think we'll have this conversation reopened again in a few slides. So can we pause to then? We did have one question from the chat, which asked, there is a must in this third bullet. Do we foresee an enforcement mechanism for any of these uniqueness constraints?
So the only enforcement mechanism I think we can say is here is an RFC with RFC 8176 language in it. And if you write a specification to say your satellite system will comply to this RFC, then it's abundantly clear. Are we having DTN police force who go out and check your implementation? No, of course we're not. If people want to do interop trials, I think the best we can do is say, we will have a clear specification with clear IETF language about the correct behavior, such that people can go away and write their testing regimes and their QA and all that kind of stuff. I don't think we're going to We don't do enforcement. We do specification.
Okay.
Okay.
Thank you.
So for service numbers, there was some confusion. RFC 6260 and RFC 7116 both said the service number for the administrative endpoint, or what it was called in BPv6 days, it was called something else, but it was fundamentally the same thing, must be 0. In BPv7, it got turned into a may. I'm suggesting it should just go back to a must. I don't see, if we have a well-known service called the administrative endpoint, why not just give it a number 0, which everyone is kind of using as far as I can work out. It's kind of a housekeeping thing. And again, 2 to the 64 because CBOR. Next slide, please. So the rename, really simple, this one. CBHE node numbers becomes BPv6 node numbers. CBHE service numbers becomes BPv6 URI service numbers. No alteration to policy, assignment, nothing. Cut, paste, rename. In fact, I think it's just rename. Next slide. Clone them, create new registries for V7, tweak them slightly. Call them the Bundle Protocol version 7 IPN scheme URI null authority node numbers registry, and I will come back to what null authority means. All values and policies are copied from the CBHE node numbers registry, except I've made the low numbers private use. I am very happy to have that discussion. I have kept the very top numbers as experimental. Again, probably part of the same conversation. Let's have it on the list. I don't mind. There are pros and cons. That's fine. There was a weird block between 2 to the 21 and 2 to the 28, which was reserved for private and experimental. That's all part of that same conversation. Let's just work out what these things should be. Let's make sure the reservations are there. This is our opportunity to do about housekeeping if required. Okay, but the key point is by putting private use rather than private or experimental, we are saying here is a chunk of unlicensed spectrum, which you clearly understand. If it's for your own stuff, go ahead and use it. If you use it in the wild, you probably will clash with other people if they're using it in the wild. This is not your spectrum to use, you are sharing it. So we could develop protocols which handle this and live in this kind of unlicensed spectrum. Someone else can do that work. I have no idea how we start there, but hey. And it also gives the range numbers back to the pool that aren't hugely high or tiny that we can reallocate for that band.
Okay. Just we
yeah.
do have 2 people in the queue, starting with Alberto.
Thanks. Can you hear me well?
Yes.
And thanks, Rick, for the explanation here. Couple of comments on this one. The first one is a question. Why creating a second registry? Why can't we extend the existing registry to say it is BPv6 plus the null identifier or null authority for BPv7?
Purely because I wanted to separate and reorganize the current assignments to clarify the difference between private use and experimental. However, I think that is a very valid point to have a discussion about what we do. And if the answer is there is no change, then we don't make the change. That's fine. Okay,
thank you. The second comment is about the use of the term unlicensed spectrum. This has huge implications when it comes to, you build technologies for coexist. In this case, I tend to agree with Mark that, selecting the golden identifier numbers for private use would automatically potentially create issues that, we may not want to have. At the end of the day, similar to IP addresses in this case, they need to coexist if they are in the same network. And that would create definitely forwarding issues if we don't create additional technology. So I wonder why creating that issue now.
2 reasons. One, having some private use, and I used unlicensed spectrum in quotes just because I know a lot of people come from an RF background, but it's not. This is about private use allocation of numbers. That's the correct phrase for it. I went for low numbers because I happen to know someone is currently deployed a DTN node that they hope will be interoperable with other DTN network that they hope will be interoperable with other people, and they've numbered 1, 2, 3, 4, 5, and they didn't ask for that. So, but again, as long as we have some private use space and people understand it's the free-for-all space, and whether we combine that with the experimental or split it, and there's a bit of nuance in the way IANA does its allocations that needs to just be checked, and it's a slightly IETF-y about it, then it doesn't really matter where it is. I just felt that moving low was useful.
Thank you.
Thank you. Kevin?
Kevin Fall, just a really small question, I think. For this slide and the other one that mentioned uniqueness in the IPN scheme, and if I want to essentially create an Anycast style environment, where do I go in terms of what allocations to use?
It's really clear.
Okay.
9171 says you don't use IPN for that. So they are.
So apologies for
No,
not
it's
remembering
fine.
that, but that seems pretty darn unfortunate.
Yeah, and I'm not trying to solve that.
Okay. All right, that's fair.
Scott?
Yeah, can you hear me okay?
Yes.
Okay, my remark at this point is just that if you do have authorities, it seems to me that the reserving load numbers for private use is moot, because the authority ought to be able to use the load numbers itself, right? And there's no, it's responsible itself for ensuring there's no clash on those numbers. Isn't that right?
I agree with you, Scott. Yeah, which is my answer to Mark originally about having them as low numbers. It didn't really matter because it kind of, once you've got authorities in place, it kind of negates and moves around that a little bit. Can we take that one to the list? Because I think it's an interesting topic. And yes, that's another aspect is, if we've got authority numbers, do we really care about this? And perhaps we should just leave it as it is. That is a perfectly valid
exactly.
point. Yeah.
Yeah.
Yep.
Okay.
So,
Okay, next is Mark. And then in the interest of time, I will lock the queue.
Yeah, I was going to say, it's fine if you want to have questions at the end, but two comments. One is same as a previous speaker, and that's Scott, Alberto. I don't see the reason for having two registries.
it was only because I changed the allocations. It's the only reason.
Yeah, but then we're kind of out of sync if someone is like,
So an important aspect is
it's not the same protocol, but I don't know.
And they are completely not interoperable.
Yeah, I know. It's the same URI scheme.
Can we take that one to the list?
Yeah.
I think it's all relevant argument. I think it's a really good discussion to have there, and I think we can conclude something practical, because it's not a major issue. This let's just do the right thing. So it's fine.
I feel bad about having same registry for the same URI scheme with different numbers. Oh.
Yeah.
Anyway, the other point is, I would like to be to learn what you mean the difference between private use and experimental, because you define it differently. I haven't seen, usually IANA, registries, private use or experimental is the same range, which is, I don't care, and those numbers should not happen in production, networks.
I was entirely with you on this, and then I went and read the very detailed RFC about how to write a registry properly, because I thought, if I'm going to do this, I'll do this. And it draws them out and explains them differently and claims them to be different things. However, if we want to conflate them together and say, for us, it doesn't make any difference, I'm happy to do that as well.
Yeah, because it's just,
Yeah. This is why this is a working group document.
And Stuart?
Stu Card, Critical Technologies. So 2 points. The first one, I think this might be a restatement of something that somebody else said, but I want to use different words to make sure I'm clear on it. That saying uniqueness means that every node number must point to one and only one node is different from uniqueness meaning that every node has one and only one node number. So I hope we can tease that out in the text. Secondly, what's a node? A spacecraft, a computer, a core on a computer, a virtual machine.
The closest I've come to that answer, and I don't think it's satisfactory, is things which share an administrative endpoint? Question mark?
Bob?
Bob Moskowitz, there was a point made earlier about, for private use, why do we need an authority for private nodes. And to that, also I say that I don't know if it's a case in your environment, but stealth mode development, where somebody's developing something that they don't want to share or something else, having the ability to get numbers to work with without exposing what they're doing is critical for those sorts of operations. So push back on any arguments against it, because again, I don't know if there's such a thing in your industry about stealth development, that there's always a government involved or something like that. But
so can I answer that question
yeah.
when we get to the authority? So if you notice, this is the null authority, i.e. you don't have an authority, you don't need to go get
Right.
an authority, you just got some numbers you can use and you don't have to tell anyone about it.
That's why you
Yeah.
want, because you have to be able to support the stealth development.
I think that's absolutely something that must be supported when, however the final text comes out.
Thank you.
Next slide. I've got 8 seconds. So the service numbers registry, just like I did with the V6 one, I cloned it because I felt that it might be worth jiggling it about to make the boundaries work with CBOR encoding. Otherwise, it's pretty much the same. I couldn't find any current specifications for active well-known BPv7 services that needed immediate assignment. I could be wrong. If you work for an agency, and I'm kind of addressing CCSDS here, who have things that they consider well-known services that are something that should be globally interoperable and registered with the IETF rather than just used within their own sort of work, speak up. Let's get these ready to go into the service registry to avoid clashes. Marc Blanchet's draft on service numbers. There you go, Mark. I did mention it. I think it's really good. It was a really timely uplift of that draft, a republication of that draft. It introduces the ping service or the echo service, needs a well-known service number just for general ops stuff, so you can ping a node, see if it is actually there in a delay-tolerant manner. It's going to need a well-known number. It doesn't have one at the moment. This is an opportunity to tidy up again. Private use, experimental use, interesting debate. Let's take it to the list. That kind of stuff. Next slide, because I just want to get to the contentious stuff. Any questions so far? No, move on. Numbering authorities. Okay, brace yourself. So allocating from the flat number space is inefficient. It is that simple, really. If you turn up late to the party, you get a more inefficient encoding for all your node numbers. Tough. That's the current state of play. Next slide, please. The proposal. Let's put a prefix in front of this. So let's divide the space from a flat space into a tree. So optionally, you can put an extra number dot in front of your node number to say this node number was assigned by this numbering authority. So a numbering authority is an organization, and there's some question mark about how we define what the credentials to be a numbering authority, to stop me going and grabbing 2 personally for my entire space race. Well, not to stop, but to ask serious questions about why is Rick registering all of 2? But fundamentally, you're saying, I can encode my numbering authority efficiently. I can then, as a numbering authority, hand out all those precious short good encodings, you know, the 1 octet, 2 octet encodings, according to my policies, without clashing with anyone else from a other numbering authority, or from that registry of the null authority, i.e. the registry used when you don't have a numbering authority. I can therefore get global uniqueness when I need it. So this is for interoperability. And it just simply encodes shorter and gives more flexibility to assignment. And if you are if you are CCSDS and you are representing multiple global space agencies, you can add naming sub-authorities to give you even more bits to play with. So you can then hand it up to 2 to the 64 sub-authorities. I mean, the big ones come with a price. And they can then, so you can have CCSDS.NASA or my global program for space domination .project A .project B, because I am a global megacorp. It gives you that little bit of flexibility, but both of these components are optional. The naming authorities or numbering authorities, and I need to be clear about getting, I've called it two different things stupidly. I've been calling them numbering authorities in the draft. Numbering authorities have a global registry in IANA. So that maintains the interoperability, but other than that, they can hand out their own numbers. And I have added a registration for them. And next slide, please. Okay, reason for it. One of the arguments is people have been saying, oh, how do I detect these things? Oh, hold on, you're changing the wire encoding for these things. This should be a whole new URI schema. No, first off, you can detect this in your stream parser or your buffered parser 1 octet later than you currently detect it. So in the wire protocol, when you receive a CBOR encoded URI, the first octet indicates the type of the URI. Type number 2 is IPN. Following that is the length of the array, which contains the integers of node number and service number. Currently, it should always be 2 because that's all that's defined. With this change, that number may be 3 or 4, and that tells you how many more you need to read. So you can detect these just as simply, but 1 octet later. I consider that easy. Backwards compatibility. They're optional. You don't need them. There's a registry. Go do what you always did. That's fine. That's it. Absolutely fine. And yes, and it also removes contention on that registry. So that's a no-brainer. We don't have everybody fighting for that single numbering range for their assignments. They can just ask for a number, or look at the numbering authorities that have registered themselves and ring their closest who's offering the best prices if you want to use a commercial model. You know. Next slide, please. That's it. Right. How big's the queue?
The queue is a very good size right now. It is empty, but I know that we had some questions prior. So well, I will bring back up in this instance. Oh well, I'll let Scott go first and then ask my question. Scott, go ahead.
Actually, if you want to go ahead and ask the question first, that's fine with me. I can. Why don't you start?
Sure. Okay. In reference to the understanding that different nodes cannot have the same node number is a different consideration than a single node cannot have multiple node numbers. Those are two separate constraints. Is there? Can I call for opinions on whether both of those constraints should always exist? Should there be a one-to-one relationship between nodes and numbering authority, sub-authority, node number? You know, that set of identification. So I will toss that out there in case anyone has opinions on that, if they would like to come up and speak to it. But then otherwise would go back to Scott for his question.
Why don't we do Scott now, and then people can consider.
Yes, Scott, it's to you.
Okay. Well, I will start by responding to your question. And what I would point out here is that both the IPN scheme and the DTN scheme are valid and are defined in 9171. So there is already a precedent for having multiple unique node identifiers for a single node. That is, the IPN node number is not necessarily the only unique identifier for that node. There can be a DTN node identifier as well, and so the possibility of aliases in that sense already exists, and it's, I would say, difficult to legislate it away. I think it's bad practice for a single node to have multiple node numbers. So I'm not opposed to excluding that in a specification. I just want to point out that there are there are existing mechanisms that can frustrate that sort of uniqueness if we want to. And those are difficult to banish. I definitely agree that that the same node number should not be used for multiple different nodes, and that I think is an important thing to document in the specification. I would also point out that node actually is a technical term that is defined formally in RFC 9171. The other thing I was going to bring up at this point is if if we say that there are authorities and the absence of the encoding of an authority in an IPN endpoint ID implies a null authority. I would suggest that null authority, think of it as an authority that is there's nobody managing it necessarily, or that there's an authority numbered 0 someplace that is in charge of it, and not even have a node number registry in IANA, since node numbers are going to be assigned by authorities anyway. So if you want to have a formal central location for assigning those node numbers where there's no specified authority, I think that's the easiest way to do that is for there to be a 0 authority whose job it is to do that, and then everything is in the same model, and you can eliminate IANA having to be responsible for handing out node numbers.
So Scott, can I reply to that one?
Of course.
So I think we are in effect creating a 0 naming authority, and it's called IANA, and it's maintaining the registry of things we've already handed out to people so that they don't suddenly lose their allocation. But what we're also saying is, because it's 0, and if you notice in the draft, I have reserved the number 0 in the number naming authority. You can't go register 0. It's held back. All we're saying is, if your naming authority is 0, you don't need to put it in there. And then things which are currently not putting anything in there and using that registry just work. So I think we're kind of agreeing here.
Yeah. I was just arguing for having something other than IANA handing out the 0 authority node numbers, because I thought it might be easier. But if that's the best choice for everybody, I'm fine with it. Yeah.
So it's certainly by having that, the existing behavior of node.service is unchanged. But if we feel any differently about it, I would say let's take that particular part to the list.
And then the other thing, of course, I was certain to bring up is a preference for limiting the size of authority numbers and the node number assigned by an authority to 32 bits each, so that they can be combined into a 64-bit node number as they currently are, and minimize the impact on existing implementations and deployments of DTN that use the IPN scheme.
So Scott, I got a response to that, which is two-part. First, I don't want to now reduce the existing 2 to the 64 address space that is through the null authority, the behavior as it currently stands, which is you get 2 to the 64 services and you get 2 to the 64 node numbers. I don't want to suddenly say, oh, and with this change we've just halved, not more, you know what I mean, we've gone down to half the number of bits you're allowed now. That's a real change. And also in in my implementation, I'm using AVX 512-bit wide multiplexing instructions, so I can load all 4 of these numbers into single registers and do high performance math on it, and I don't want to lose that ability. So, and that's an example where what works for one implementation doesn't work so much for the other, and kind of we're supposed to be
but
setting
I'm
standards
confused
rather
though.
than looking at implementation. So I don't know.
Wouldn't the 64-bit combined authority and node number and aggregated work just fine in your environment? And conversely, 128 or 192 bits would work very, very badly in environments that are much more constrained, such as a lot of spacecraft.
Conceivably, but I think it's less important than breaking backwards compatibility. I think that's more dangerous. I think if we turned around to CCSDS and said, no, in fact, who is it? It's spacely packets have number allocations outside of the 2 to 32 range in the IANA registry, and we're basically turning around to them and say, I'm sorry, your registration just got removed. I don't think we can do that.
I'm confident that they took that registration because that was the rules for IANA allocations, and I'm confident that they don't want necessarily numbers that are bigger than 32 bits.
I think Scott will join us and tell us.
I think they'd be content. I think they'd be content with numbers that are much smaller than that, and I think that in practice, numbers that are bigger than 32 bits are in general not being used.
Okay. All right, let's stop this one here. We do have a couple of other people in the queue. Scott, sure. I asked that you repost this to the list so that we can have any remaining conversation. And I asked that as we go forward, we get a chance to clear this queue quickly so that folks like Scott will have time at the end of the meeting. Alberto, go ahead.
Thanks, Ed. Quickly, just to give my opinion on the uniqueness of the node number. I agree with Scott on the first one, which is I think we shouldn't prevent a node having more than one node number, or a processing unit having more than one node number. And then on the second one, I'm not sure we should be imposing that limitation when we think about potential distributed implementations in ground to have something closer to edge processing that might require depending on the implementation, that might require to the option to have that the same node number in different processing units. This may be at the same processing unit, but I'm curious about whether that limitation would impose or limit any of these implementations.
And Alberto, my request, same as Scott, is if you could make a post to the mailing list specific to that topic, and we could capture what is likely to be very good discussion around that there.
Thanks. I will do. Thanks, Ed.
Brian.
Brian CPS APL. Just mention, and I put this on the list too, that IPv6 made the same kind of clarifying distinctions between the node and what they call the interface for address assignments, and the same kind of thing could be done here to just clarify what actually has the number assigned and what is the logical aggregation.
Can I reply to that one? Thank you, Brian. That's a very valid point. From my perspective, we should be identifying nodes and not interfaces. I'm with John Day on this, that it was a mistake. I mean, I see why it happened, but I don't think we should do that with DTN because we don't have host names. We just don't have them. So let's get that right.
Okay. And Rick, you were in the queue.
I was in the queue, but I've already made my comments, so I will yield.
To Bob.
You were putting on IANA some very specific work. Have you asked for an early IANA review on this draft?
We will be very soon. It's only just been working group adopted, and yes, we will.
Okay. I've also gone through early reviews, and they are extremely important and valuable.
Completely understood and noted. Thank you.
Felix.
So this is Felix. So I would like to go for something for the IPN naming scheme that you simply say a node is something which has a single and just a single node number. I think it will make everything much easier to understand. I don't want to have a node number which is shared across multiple nodes, because if I would like to base my routing on node numbers, it will not work anymore. At the same time, I don't see a reason why a single node should have multiple node numbers. If I need multiple node numbers, I can just make multiple nodes. I think also the argument from Scott does not really hold here, because these are really separate naming schemes. So there's no danger of confusion, for example, regarding the service numbers. So if I see it as a kind of alias, I'm not sure if I'm talking about an endpoint ID 1.2 and 2.2, whether it's actually the same service in the end, or whether it's really separated. The same is for me, I have similar things regarding the administrative element. If it's an alias, it would be the same. If it's not the alias, I would have a node with 2 administrative elements. So I think unless we identify a clear use case, we would say single node, multiple node numbers, we should not try to go that way, because it will really create, in my mind, it would create difficult problems. And I guess these questions, whether this node, this service 1.2 and 2.2 would be the same, would probably also have pretty different answers in the room. So it's just confusing for me. So unless we have a very, very clear reason, we should not do that.
So thank you for the comment, and also ask that you reply with that because the best part of capturing this is the traffic in the mailing list.
So my final response to Felix, and that was the thing I remembered that I yielded on. I actually think one of the beauties of IPN is its simplicity. I mean, yes, I turned around earlier and said, you know, no Anycast, no this, no that. It's unicast, it's simple, it's got basic numbering, it should be really tight and light. And that could be a very good reason to say, of course, we can do multiple node numbers onto a single node, but that is perhaps going against the spirit of IPN. And remember, we've got this DTN URI, which is very rich and completely unspecified and can be used as a dumping ground for all this cool stuff. So why not keep IPN quite simple? That's my closing comment. Thanks, guys.
Thank you, Rick. Next, we have Brian Sipos. Brian, I'm going to ask, instead of the 30 minutes that we have allocated, if we could pull this down into 20 or so. And why don't we start with BPv7 administrative record quick conversation.
Sure, yes. So I didn't prepare slides for the administrative record topic only because the document itself was not changed. It was only recently adopted by the working group. There have not been any substantial feedback or comments yet on the document. There was one editorial change to clarify that it didn't change the IANA registration policy. So it's just clarifying that there is no change in the policy. So that document has now been adopted by the working group, and a new version has been uploaded for the working group. So really, at this point, it's just soliciting feedback and comments.
Well, may I then ask the working group to please take a moment and read this this newly adopted draft. It is short, and please provide comments on it. If we don't get comments on it within the next few months, then we will assume it is ready to go into the next step in this process.
And I will mention also that the ACME working group and the security area director are depending on this document to progress to the IESG for the other work to continue.
So with that, we can then move on to the next presentation, which are the COSI BPSec security contexts. And Brian, are you able to share your screen?
I should be able to. No. Is there a way to get the slides up? I don't know that I can.
So there's a little, hi Brian, there's a little button under your name in the top left hand corner of Meet Echo, which says, it's got a like kind of file icon that will share preloaded slides for you, and then you get the thing at the bottom.
Perfect. Okay. So this is discussing an individual draft currently that I would like to eventually bring into the working group. I've prepared previous slides, and these ones are very similar, so I'm just going to go through quickly as background. The context here is that the bundle protocol already has what are called the default security context that gives some basic symmetric keyed algorithms, and they do their work well, but they're limited to the symmetric key, and they're limited to some narrow situations. And for larger networks, for internet-facing nodes, and even for currently envisioned networks that are coming out of the IOAG and NASA, there is a need for PKI security. And this is just something that also falls in with the general overall best practices of current internet and network authentication and security. And we don't want to have to reinvent the wheel for how to do either PKI or to do the algorithms that rely on PKI. And so what this is proposing is to use the COSE message encoding and algorithms in BPSec. And actually, since these earlier slides, COSE has actually advanced to internet standard. It was draft standard previously. So the high level goals here are, we don't want to alter any of the BPSec structures. We don't want to alter any of the existing PKI infrastructure that already exists. And we want to reuse as much as possible both the tools and the protocols. And the other thing is that looking into the future, we want to get gains that others are making in the domain of COSE. So COSE already has working groups for using more experimental things like compressed PKI certificates and post-quantum and hybrid cryptography. So the goal here is to eventually be able to take those benefits with very little tooling change in the bundle protocol. Now, I'm not going to go into all the details about the current COSE context, but the concept is that it's reusing existing logical structures and reusing existing encoding structures. So it's very little new for this context. And the key thing about making this work is that we have an interoperability profile. COSE is more of a container for security information. It requires a profile to be able to say, here's what actually is expected and required of the message content. So this minimum interoperability profile, and this is something that we can negotiate and work out what in here is actually required, what in here shouldn't be required, what in here might need to be prohibited. This is really the meat of what this document is combining together. And the focus currently is on PKI algorithms. And here you can see that the elliptic curve algorithms, RSA is represented, but things like more experimental HPKE and post-quantum stuff doesn't exist here, but in the future it could be expanded. The main goal though still is to get BPSec working with current existing PKI tools and systems. So that's the push here. And as it's written, as it currently stands, this is a mechanism that is usable today. You could actually use this with pre-existing PKI and the existing certificate profile that was established in 9174. And that is the end of my presentation. So both feedback is welcome on this document, as well as if it seems valuable enough to have it adopted to the working group.
So is that then a request to the working group to consider adoption?
Yes.
We have one person in the queue, Stephen.
Hey, Stephen Farrell. So I think this came up when the ACME document was being processed, I guess, was the extension to ACME to automate validation of a node ID. You say that's the next step. Do you mean that thinking about that is the next step, or you have an answer in the document already? I haven't read the document, sorry.
Oh, no, the relationship here is that the ACME extension that is already in that working group, that is intended to address where did these certificates come from? How does an authority validate these identities? This document is saying, how do we use the certificates in BPSec? Currently, the certificates are profiled for TLS for being used with the TCP/CL, but this is saying we can use them also for BPSec so that we can get end-to-end security, whereas TCP/CL is single hop.
Okay, so I guess the comment is I don't think it's fully figured out how you might do the equivalent as to what, let's say, Let's Encrypt do with DNS-based domain validation. So I don't know that there exists an equivalent to that that's useful, and I think that that's probably warrants a bit of
Okay,
work.
so that actually is the other document, the ACME document. That's the intent of that.
Right, but as I recall, so I did a quick review of that because somebody asked me, and if I recall that document just said, oh, there's a problem there that we don't really know how to solve, but maybe I'm mischaracterizing it.
No, it's actually gone through working group last call, and it does have a specific explicit method of doing node ID validation.
Okay, in that case, my claim is that when I reviewed it, I didn't think it was that convincing.
Okay.
Stephen, I think that's resident in ACME. That's an ACME document. So, I mean, we'd love to see it happen. If you want to go and poke ACME to get progress on it, we'd love that. But I think it's an ACME document, that part.
And based on, I do know, based on your feedback, in the ACME working group and for the purposes of ACME, it is an experimental method and an experimental document.
Right. So my recollection of the resolution in the ACME working group was, we kind of notices that, acknowledging the lack of existence of something like domain validation was where that ACME document seemed to land. And what I'm saying is, if you want to figure out something better, that's probably something to do here, because it's only here that you really know how could you meaningfully have some clue that a node ID corresponds to some key pair.
Thank you. Bob.
I have a bit of a point of information here as you're moving and looking at PKI. The International Civil Aviation Organization, ICAO, has plans in development on an international scale PKI. They have a CP policy and the rest of it, the whole model for including all member states in this PKI, all 179 signatures to the ICAO treaty. And many of the organizations like NASA and so forth will end up being part of this for their aviation components. So I recommend that you look at this particular PKI and how you can potentially leverage it and the policies and the C organizations which will be rolling this out over the next couple of years to be able to leverage it and take advantage instead of doing yet your own PKI and all the tremendous headaches that entails. Because for those of us who've lived PKI, it hurts a lot.
Absolutely, and that is one of the points of using these existing structures, is to not have to reinvent the PKI. This leverages all of the existing X509 PKI infrastructure where
Brian,
it exists.
You also mentioned that you had a short set of slides on an additional topic. Can we go through those?
Yes.
In 5 or 6 minutes?
Yes.
Okay.
Yep. Do I need to switch or change deck? Okay. So this short topic is about CLA services, and the short background is that there was some earlier discussion on the mailing list about can we define a generic sort of abstract definition of what a CLA is supposed to do in its communication with the bundle protocol agent. And currently the lack of a common logical interface has risks in that implementations are free to completely choose how a BPA and a CLA interact with each other. This means that it's inevitably going to result in different terminology. in the CLA implementations, different terminology in the BP implementations, different configuration between the two, and potentially a lack of interoperability of people's understanding and configuration of things. So this is not talking about on the wire interoperability, but this is talking about when I say I've acknowledged, when I say a BPA has acknowledged reception, what does that really mean? Right now, there isn't really a clear definition of that. And what this also does is it makes it more difficult for a node implementation to swap out a BPA from a CLA from an administrative element. Right now, those three layers are distinct in RFC 9171, but in implementations, it's not so easy to swap out. Somebody else has a really good CLA and I want to use it with my BPA. If they're not following the same service model, they're not going to be able to work together, and it becomes really difficult. So I'm going to skip over the goals, but the basic thing is that it's a logical definition. It's not an API. It's not talking about changing to CLAs. It's not talking about making changes to any of the existing definitions. It's trying to come up with a harmonized definition of what's happening in the same way that when we talk about network traffic versus something like a POSIX socket interface, it gives people a basis of how to think about things and helps understanding and interoperability. So this is a summary of the current service listing in relation to the current UDPCL, TCPCL, LTPCL, and BIBE. And the goal is to get feedback on all kinds of strange CLAs that people have been and plan on using and how it fits in with this model.
Oh, go ahead, Rick.
Rick, chair hat off. I think this is great, Brian. I think this is missing. I would love to give you a better review, and I will go look it out when I get a spare moment. I think it is really important work. I think it also has use not only for CLA implementers and BPA implementers. I also think it helps guide the working group into understanding what we're doing with forwarding, because forwarding fundamentally is selecting CLAs. Understanding what a CLA can do clearly will help us clearly understand how we express forwarding and how we get on top of naming and addressing, because there is still some confusion amongst all of us, and some of it goes back to the confusion about what a CLA does, doesn't do, and fundamentally is. So I totally support getting it written down. So
and the other interesting thing on that same topic is that there have already been in the Appendix A discrepancies identified with the TCP and the LTPCLs. And these are discrepancies that are not necessarily things that are wrong or incorrect about the spec, but things that are just left open-ended, that implementers are free to do what they will, but if they choose different options, they are losing some aspects of interoperability. So part of this is just saying, beware, be careful, or negotiate. You know, different implementations need to negotiate on certain points that are not specified.
Cool.
Oh, thank you. Hey, Brian, anything else before we move on to the next presentation?
Only that feedback and contributions are welcome. This is not being requested as a working group adoption at the point, but getting some feedback is helpful. Thanks.
And just to echo Rick, this is tremendously, would be a tremendously nice thing to have, and a request that you also start a thread on the mailing list to solicit those comments.
And by extension, a request from me to the working group to say, please join in that discussion. Let's kind of get this done. I think it's handy.
All right, the next presentation is Sarah Heiner, who is going to be giving updates on the DTN management architecture, not the DTN management architecture.
I think that's better.
Yeah.
Okay. So Sarah Heiner presenting the DTN management architecture, not DTN MAA. Oh, sorry. I'll do my best, but please remind me if you aren't hearing me well. So I'm going to be talking to some of the highlights and changes that we've made to this document, but there's of course not enough time to address everything. So I would definitely encourage you to check out the most up-to-date version, which I think is version 3, which is posted online, but we'll talk through the problem space and then get into some of the highlights like the reference model and autonomy model. So as a quick sort of rapid fire introduction to the DTNMA, you might recognize it as the AMA, which was the asynchronous management architecture. We've renamed because asynchronous doesn't capture that problem space the way that we had hoped to. It wasn't the right term to be describing this work. So for now, at least as a useful placeholder, we've switched asynchronous out for DTN-based management architecture. And the 3 main components of the DTNMA is the response to needing to support asynchronous behavior. So acknowledging that your managed and managing device are not always going to be in constant communication. We need an autonomy engine to enable self-management of those managed devices. And we need compact encodings that are provided by our naming structures to address the fact that we're operating in a constrained environment. So really high level overview, but we'll dig into these pieces. So the first change that we made to the document was defining the problem space a bit better. So we started by identifying a DTN as a constrained network, which emphasizes why we are interested in compact encodings. And then we refined that definition further to say that a DTN is also a challenged network. So that addresses the asynchronous nature of the communication and the fact that we have to deal with challenges like disruptions and delays, which makes us focus on autonomy as a way of responding to some of that. It's apparently a wonderful point that I just made. So after we defined that problem space a bit better, we took a look at the existing network management work to see what could inform the design and the structure of the DTNMA. And as a quick review of some of that research, we took a look first at SNMP and NetConf and said that that well-structured approach was good, but the low latency sessions that we need to support an approach like that are not something that we can guarantee in a DTN. We moved to looking at RESTconf, which is stateless, but it still requires the use of HTTPS and in some cases large data transfers, which again, we can't guarantee. And then CoreConf, which is running over CoAP, that provides the concise encodings that we were looking towards because they use CBOR for encoding, but they still require transfer of data using the Yang schema and don't provide the autonomy model that we felt we were looking for. Next slide, please. So I've tried to distill that research into something to let you visualize this problem space, but I will definitely issue the disclaimer that this is an oversimplified view into this problem space. So bear with me in trying to justify how you should look at this diagram. We think that the DTNMA fits into the intersection of these 3 circles, these 3 priorities for this network management approach. And we acknowledge that there is existing good work in all of these circles, but we haven't found something that lies at that intersection. So the DTNMA, for example, prioritizes autonomy. There's work done in the ANIMA group here. But this is for distributed calculation of network data for data centers. It's not experiencing the same constraints that we might in a DTN. Similarly, there is support for asynchronous behavior by RESTconf, but again, requires running over HTTPS. Using CoreConf, we're getting those efficient encodings, but there is no autonomy model that's associated with that work because that was not the focus. So work in all of these three distinct areas, but how do we find a solution that gives us all three? Autonomy, support for asynchronous behavior, and those efficient encodings. So following through on some of the feedback that we got from the working group, one of the changes that we wanted to make was to update the DTNMA reference model. So on your left, you'll see the old AMA model. And the feedback was that this was just too generic in describing the autonomy that we needed. So we've updated the DTNMA model to show the use of an autonomy engine and how that's configured with policy. And I promise that this figure will get a lot larger as we dig into the details there. So don't hurt your eyes trying to look too closely just yet. So before it gets even bigger, I promise, we will actually talk to the details here. I just want to highlight the three, what I feel are main points for the reference model that enable device self-management, which is ultimately what we're trying to support with the DTNMA. So first, we are making use of pre-shared definitions. While I can't guarantee that the managing and managed device are always going to have a connection, we need to take advantage of the times where they can have those brief periods of connectivity. So in that moment, there is data and models that are going to be pre-shared, and the managing and managed device are agreeing on data definitions so that they can continue to work when they are not connected. The second major piece is the DTNMA's agent self-management. So this is where that autonomy piece comes in. That managed device is often going to be disconnected, and it needs a way to act on the policy sent over from the managing device to tell it to react to different events and how it should be handling those different events. And then the third piece here is command-based management. So a command and control interface that is provided for that managing device to get information like policy over to the managed device. Since we can't support bulk updates or moving large data stores back and forth, we're instead using that command-based management. Okay, so details as promised. So we'll start at the bottom of this diagram. We're operating in a challenged environment, so real-time data negotiation is not always guaranteed. So we need to pre-share information between the managing and managed device. And this includes information that supports our autonomy model, also ADMs, or the application data models, which are standardized data sets that both the managing and managed device agree on. And then we'll talk first through the managing device and then move over to the managed device. So at the top of the managing device are the applications and services, which are the source for policy, which informs autonomy. So these applications and services are creating policy statements, and they're also the target for reports which are coming back from that managed device. They are operating with or without an operator in the loop, and this is an example of an open loop control. The DTNMA manager, which sits on the managing device, serves as the interface between those applications and services and the DTNMA agent. The DTNMA manager will take the policy statements from those applications and services and translate them into something that the DTNMA agent can understand. So in this case, those are rules. The DTNMA manager is also responsible for reporting. That's receiving reported data back from the managed device and then distributing to the applications and services that need it. And then administrative configuration, so keeping track of things like agent mappings. And then if we move over to the managed device, we also have applications and services sitting here. And these are being monitored by the agent, which also sits at the managed device. And the agent is using a control interface into these applications and services to collect state information, to alter the configuration of these applications, and also impact their behavior.
And we have one question from Rick.
Thank you, Rick. Hat off. You've got applications and services on the managed device, and I think I understand what those are. But you've also got applications and services on the managing device. Are they the same ones, and there's some kind of mapping, or do you have managing applications and services that are talking to applications and services that are being managed? I've just got confused because it's the same text in both places. Are you doing digital twins? Or are there just two different groups of apps and services?
Two separate groups.
Thank you. Fine.
Thank you, Rick. And another question?
AJ Beal, Naval Postgraduate School. This is a really helpful talk to kind of frame a lot of this. The interface with application and services going down to these controls. Could you speak at all to some of the transport control of that? Is there a verification of delivery that's ever done? Because obviously on DTN's packet loss, things not actually arriving at the destination is a huge concern.
Sure, absolutely. And can I talk to Ann at this?
Sure, absolutely.
So the asynchronous, which maybe is still not the right word to use, but the asynchronous management protocol is something that we've proposed to be sending these controls back and forth from the managing and managed device. But I think that something that's valuable about this approach here is that underlying transport to send those controls. I think that is still flexible. We're not tied to what we've chosen at this point. But
what was that the question you were asking?
I guess it's if we think of like TCP addressing everything delivering, that has a historically hard time on these networks where the cause of packet loss was not congestion, and just this being the working group that might have better ideas of optimization for addressing that in a tolerant network.
So can I just jump in this Rick chair hat on? I think the answer to this is held elsewhere, because what we've done is tried to separate the reference model for architecture from the protocol specifications and the recommendations for each of the lines which actually do the communication. So if the communication between the managing and managed device that was running over DTN, then the architecture, ignoring what it runs over, the architecture will say, you will need some reliability, or if you don't have sufficient reliability, here are things that must be considered, etc. So it's describing a framework and reference model. And I know somewhere in the pipeline, whether it exists as a draft or just in people's heads at the moment, saying, and here would be an implementation on top of DTN, possibly using custody transfer bundle in bundle in order to add that reliability constraint, requirement to meet the requirement from this reference model. So it's kind of where we're splitting a very big piece of work into the bits which need to be specified and standardized, and stuff which implementers can go away and find cool tech that they have to fit the gaps, if that makes sense.
Yeah, absolutely. And thank you. That framework helps.
And I would just add a comment to Rick's comment, which is from an acknowledgement perspective, because certainly one of the questions is when policy is generated on a managing device and is then sent in some way to a managed device, what is the acknowledgement associated with that? Some of that is considered and held at a transport layer. Did the policy actually get there to be unwrapped? Alternatively, some of the policy in an open loop management system could be when your policy has been received, one of your policy actions is to produce and publish data associated with this new update to the system. And so there are sort of a couple of different ways in which a managing device could get information back that something it had sent prior had been received, either because there's a transport acknowledgement that it was received, or there's new behavior, such as additional reporting that comes back from the device. And then you know, because it is doing this new behavior, it must have received its new policy. So there are a couple of layers where that kind of question could be addressed. Thank you.
Great. So then next slide, moving to the DTNMA agent. So the DTNMA agent is interfacing with a few pieces here. So monitoring the state of the applications and services that it knows, and doing that without a regular connection to the managing device. It's doing that by maintaining the rules that are in its autonomy engine. So these rules are instructing it to act based off of the state data that it's sampling from these applications and services. It's also performing data fusion, so creating new data values or putting together reports based off of the common understanding of data definitions from those pre-shared definitions at the bottom of the diagram. And then again, performing some administrative configuration, so keeping track of the mapping to the managing devices, for example. Next slide. So I've been saying autonomy quite a bit, but now we get the chance to dig into the autonomy model a bit better. And the autonomy model is important because the manager and the agent, again, will not be in constant communication. So how does the agent know what steps to take based off of the data that it's sampling? So if we start at the top of this diagram here, the manager is sending policy expressions to populate a rule database that's local to the agent. So these rules are, if a stimulus event occurs, then respond with this action. And those rules are informing the agent of how it needs to be reacting. And the next slide to talk to the bottom. So when the agent is acknowledging one of those stimulus events and needs to react, there are several ways that it can do that. It might impact the local rule database itself. The autonomy engine may also issue an application control, so in some way impacting the behavior or configuration of the applications that are being managed. There might be a generation of a report to get data then back to the manager, which is in charge of then distributing that further. And it might also update the runtime data store, which is local to that DTNMA agent, but is updated as well by the manager in times of connectivity. So populating information beyond the standard agreed upon data definitions that are a part of the ADMs. I think that that's my last slide, so if there are questions.
I'm going to jump the queue because I'm sat in the chair. Thank you Sarah, I think this is really good work, and I know there's many other people involved behind the scenes getting this document put together. I think this goes back to my earlier comment about framework. Having a framework where we can talk and address about these things in generalities without getting caught up in binary representations and wire protocols and all that exciting stuff, and actually understanding what we're trying to achieve, and that very simple but effective and non-Turing complete rules-based system. That's very clever stuff. And yeah, can I request to the working group, please review this stuff. This stuff is clever, and it needs a lot of eyes over it, and it's an enjoyable read. So thank you.
Alberto?
And Sarah and others for creating and updating this document. It is a great read. Rick, I echo your comments. I encourage every single attendee to read the document. It's very informative and put a clear path to implementation. I have a few questions. I'll be sending all of them through the mailer list, but I think some of these are interesting to the audience. The first one is why are you referring directly to BPv7 only in the documentation instead of BPv7 and BPv6?
Well, so I can jump in on that just for a moment to say that we actually have users of potential users of this model that aren't using either BPv6 or BPv7 or BP at all. So I don't know that that we specify or require BPv7, but I kind of jumped ahead. Sarah, if you had an answer to that.
Oh, it was hard for me to hear the answer to the question. So honestly, I was just going to ask for a repeat. Sorry.
Yeah. Okay. Yeah, it's not mandated, but there are, even in the abstract, it goes straight to BPv7, and every time bundle protocol is mentioned, it goes straight to BPv7. So I was curious to see if there was, any specifics there. The second one is more a comment. I went through the document. The use cases are fantastic. One thing, and this is analogous to the discussion we had around BPsec security context. It's that it doesn't talk about coexistence with non-challenge segments of the network. Especially when we think about DTN networks and the ground components, how you envision the architecture could coexist with other management implementations, or how DTNMA would run on scenarios that are segments that are not that challenged.
Sure, that's a great point. That we want to develop an architecture that is robust enough that we're handling the challenges, like I mentioned, with a DTN, but at the same time, we don't want to be so focused on addressing challenges that we can't take advantage of the underlying strengths of different network segments. Definitely an important point.
Awesome. And the last thing, and this is very specific, there is a, I'm sorry, go ahead.
Sorry, but I think both Rick and I had also a quick follow-up comment to that. One is several IETFs ago, we had someone present whose master's thesis was a netconf to AMP bridge to serve that kind of boundary. And if you can find that in the meeting minutes, for a past IETF, please look for it. If not, send me an email and I can find it for you.
Awesome. We'll do so. Thanks.
My quick response was, having had the clarifying question, my question clarified earlier on, the applications and services on the managing devices, one of those or more of those could be interoperable bridges with existing management systems, and that's how it plugs into the model. So you could view those as upstream management devices.
Okay. Awesome. And sir, there is one thing that puzzled me a little bit on the intermittent use case. There is a sentence that says that in case of disconnections, the agent may store those reports or may rely on the underlying transport protocols. I'm a bit I was a bit puzzled because I think the whole idea was to rely on bundled protocol type of networks, but then if we're imposing storage constraints or not constraints, but if we're implying that you may need to store messages, I'm not sure how this would would help the whole architecture.
So if I could just jump in for a moment.
No,
Okay.
no, go ahead. Go ahead.
You're on the mic. Speak.
So the concern is a reliance on a store and forward network, while we're also making the claim that we are not dependent on running on BPv7. Is that your?
Well, it's it says that the agent may store the messages or the reports until the link is available, or it could rely on the transport protocol. So I think that that poses me a little bit, because the whole at least the rest of the document tends to imply that things like a store and forward are
All right. Noted. My only comment was to say as well that there are some instances of perhaps use of this architecture in places that are not running over bundle 6 or 7. But certainly if bundle is there, it provides this service.
Okay, thank you.
Thank you for the close read of the use cases and otherwise.
So thank you so much for the presentation. Excellent presentation. My request for the working group is this document is an update to the original AMA document, and we would like to finish it. And so if you have not had a chance to read it, please do. Please provide comments back to the working group mailing list. All right. And next we have Scott Johnson, who wants to provide a demo of IPv6 support for DTN. Scott, would you like to have us present anything, or would you like to share your screen?
I think I'm going to go ahead and share my screen, if that's okay.
Sure.
Okay. So I'm going to go ahead and do that. And we have an input loop. Okay, and so hi everyone, I'm Scott Johnson, and I'm presenting live from inside Hurricane Nicole, as you can see here. I could tell you about myself at this point, but I would rather talk about ideas, so I'm going to do this the Hawaiian way and talk story a little bit in lieu of autobiographical content. The title of my talk today is Extending the Reach of Delay-Tolerant Networking into IPv6 Networks, or the Ultimate NAT Avoidance. As some here can attest from bearing direct witness or their own personal participation, the internet was conceptualized and designed to provide end-to-end connectivity between any two publicly numbered hosts. Between then and now, things have changed. Address scarcity due to use and monetization has led to the rise of that scourge NAT in IPv4 networks. A spot check pins the going market rate for IP address transfers at approximately $50 per IPv4 address between ISPs. Consequently, retail cost to the consumers has risen. A premium on static addresses to the consumer further encourages the use of that foul kludge NAT and further breaks the end-to-end design principle. But hold, there is a way to restore this core concept into the evolving, growing network. It is IPv6, and it holds the promise of addresses aplenty for all, just as it has for a couple of decades now, since we stood up the 3FFE 6-bone networks and put the protocol through its paces. In these days, over 80% of mobile networks are numbered uniquely only with IPv6, according to a recent Internet Society study. These edge clients have a particularly nasty strain of NAT called DS Lite used when connecting to IPv4 only hosts, which makes an IPv4 in IPv6 tunnel to forward NATed packets to the client via dynamically allocated RFC 1918 address space. So in short, we have IPv6 native mobile networks check off of our list. The largest reaching ISPs in the ARIN region are now widely deploying native IPv6 service to the client devices via Slack or DHCP6 at the CPE. From speaking with colleagues in other RIR regions, similar or better deployment is generally the case. This tends to restore the property of end-to-end connectivity network-wide, eliminating the need for NAT and NAT traversal techniques when trying to use the internet as designed, allowing universally accessible services to be offered, if desired, by client devices on the edge of the network. Adding to the tally, IPv6 native fixed access networks, check. By adding IPv6 functions to applications previously only capable of IPv4 operation, the reach of those applications increases significantly all the way to the modern terrestrial network edge. This presents distinct opportunity for the DTN community. IPv6 enablement of BP-based applications allows scalable protocol stress testing and new application development due to increased use case scope for delay-tolerant networking. In this light, I have endeavored to add IPv6 support to the open source branch of JPL's implementation of bundle protocol and the associated software suite ION. Thus far, the IPv6 enabled UDP, LTP over UDP, and TCP convergence layer adapters have been completed, as well as the new core library functions which they call. These convergence layer adapters have been tested in both private LAN environments and in coast-to-coast tests on publicly numbered networks. As I demonstrate these three modes of IPv6 operation running on a single node concurrently for you, I would ask that you all consider which other protocols that are implemented in IPv4 capable convergence layer adapters are most desirable to be ported to IPv6 operation next. And so what you're seeing here is 5 different nodes. On the top left, the larger terminal is the primary node that I'm going to be running the demonstration from. The remainder of the nodes will be receiving BPings and responding, knock on wood, because this is a live demonstration. I've written a small script here to perform various functions to keep me from having to type things. So here's a list of running convergence layer adapter protocols on this node. You can see we're using LTP, UDP, and TCP, and this is the command bpadmin L protocol showing this. Now we need to press only the any key to continue. Here we're listing all bundle protocol inducts on the node. You can see we have an LTP node that is numbered with spacely packets allocation. And then we have UDP and TCP convergence layer adapters, or inducts rather, that are listing on that IP address. Here are the adducts for the node. We have a loopback on LTP and then 2 remote nodes, being 2 of these here on the screen. The UDP and TCP representations there, as well as the active TCP socket at the bottom. Here's the local LTP seat that's running. Here are the LTP spans that are running. And we're going to ping all of these nodes to make sure we have connectivity before we bping test. It's worth noting that the top left that's pinging now and the top right terminal are running on the same host under different user accounts. And both of those are running on a BGP speaking router, which is announcing the IPv4 and IPv6 addresses that are being used. Here are the open sockets on the machine. And here we have our bpings. You'll see in the bottom left, we have our bundles being echoed back, our visual indication of the dots across the terminal. And so that is from California to Florida here in my data center, which is underneath the hurricane. This is locally on the same host from one user account running a node to another user account running a node. And this is over LTP via UDP. The first test was via UDP only. And here we are testing UDP and LTP over UDP coast to coast from California, where spacelypackets.com is residing, to my data center here in Florida. And finally, TCP functionality between Florida and California. And there we go. And so, once more to our tally, IPv6 enabled delay-tolerant networking. Check. This greatly broadens the terrestrial reach of delay-tolerant networks, enabling applications using BP to extend to the true network edge. I'll return you to my question. What IP-enabled convergence layer adapters should have IPv6 functionality added next? And I thank you all for your time.
Well, first, thank you very much. And second, Rick.
Again, thank you very much, Scott. I'm going to answer your question. I think they all should. I think we build any convergence layer that runs on top of IP should support v4 and v6. I think that's a no-brainer. I'm not meaning. I think you've done a great piece of work there. It's great to see ION v6 native. I think it's really good. But the answer is, if we support IP, we support v4 and v6. That's the way. So great to see that running. Thank you very much. It's always nice to see actual DTNs happening as a demo. So thank you, and enjoy the hurricane.
Thank you very much for having me. And you know, these networks that I operate here are designed to withstand these hurricanes through many years of trial and error. That's why we wound up deploying our own autonomous system for redundant routing.
And you have one more question from Kevin?
Yes, Kevin.
Hi, it's Kevin Fall. It's really for everyone because it's been a long time since I've put my nose into this community. So back in the day when we were sort of thinking about different CLAs and the, dare I say, the fib that you would do at a node, the vision was, oh, well, the next hop could be email. The next hop could be, you know, person on a bicycle with a USB key. Or one of my more favorites is write the message up on the wall. Somebody comes up later, copies it down, and it goes on its way. You know, this IP is obviously sort of in the IETF, but I'm wondering, has there been progress or work in any of those more kind of wild ideas we had back in the day?
So Rick, chair hat on.
Yeah.
As far as I'm aware, that is still absolutely the ambition. Underwritten by the statements convergence layer adapter, that clear separation between the act of creating, moving, generating bundles and the things which will do it. So we keep that nice layer separation. I don't believe, and I would personally strongly push back against anyone saying a CLA is always an IP-based service. Right. Absolutely not.
Never intended to be.
No, never. A man on a bicycle is a very valid CLA. A group of them is probably more effective. But yeah, I mean, reindeer as CLA or reindeer as transport, I think has been rolled out before.
I see Scott cut in the queue. I mean, there was, I recall years ago, discussions about a USB key. Is it a node or a link, for example? And it's, you know, maybe it's a beer conversation, but nonetheless, thanks.
So we have one minute left. Scott?
I can answer that actually. There or provide an answer to it. There is a member of the IP and SIG here with us, Sam Ograsic, who has just completed his first running code for a UART adapter. So that's a serial console, and that I believe he is using to connect to LoRa radios for long-range wireless terrestrial connectivity. But he can speak to that more.
hold on. Sorry, Scott. I'm gonna call out. There's a difference here. There's a difference between putting bits on the wire to carry things that are built around a TCP streaming or a UDP streaming packetized format, and the higher layer concept, which I think Kevin was pointing at, which is I can serialize a bundle in some way and give it to a thing which moves it. It's great to see, perhaps TCP or UDP running over serial, or some kind of chunking that moves bundles over serial. Great example. But I think Kevin's aiming at a much higher concept, which I agree with him of. If we can serialize it and move it, that's great.
Let me just interject here that I think this is LoRa. It actually is not TCP/IP. It's native LoRa, and you're right. Other CLAs that are not based on IP are certainly things we should be doing, and I'm going to claim that we already are.
Good.
All right, so with that, we are at time. So thank you all very much. Again, please continue to use the mailing list. And if you were presenting, please make sure to post additional questions and requests for review to that list.
Otherwise, thank you all very much. Speak to you all in Yokohama. If not on the mailing list, we might do an interim if there's excitement about it. Enjoy. In retrospect, we probably should have said we'd do an interim on the IPN stuff, but we'll do that on the list. It's fine. Have you not considered Tour de France net? Hand off USB keys with the water bottle. Did it in college?
For the cycling club and I together one day.